Alrighty, so in this video we're gonna take a look at Outbox pattern and basically how it can help us make our async messaging more reliable. My name is Vasily Lenik and you're watching the .NET Architecture series where we are building a modular monolith notification system using industry's best practices. So every pattern, every design pattern tries to solve a specific issue, which is the issue that the Outbox pattern tries to solve. To understand that, we're going to take a look at a small code snippet. Basically, this is a generic method that we might see in our code base. So we do some business logic over here, we add an entity to the database, we save the changes, be it a repository or a unit of work, and then at the end we try to publish a message or an event. And what's the issue here is basically this part at the end, the message broker.publish, because no one guarantees you an 100% uptime. At some point the message broker might be unavailable, and since this one throws an exception, the business logic beforehand has already been saved to the database, and we have an inconsistent state where the business logic has been executed but the event has not been sent to the consumers or to the subscribers of this event. If you're using unit of work and you're basically creating a scope of unit of work by using middleware, be it the HTTP request middleware, be it the mediator middleware, there is a pattern where you create the unit of work at the start, then you save the changes at the end of the middleware. So in those cases, you might, for example, publish the message to the broker, but then the database transaction fails for whatever reason. And you might find yourself in another peculiar situation where you have already pushed the event, however, the business operation did not occur. And that's really a state that you don't want to find yourself. Now, how does the Outbox pattern work? You're basically just gonna store these events in a local table, and then an async job will pick up those events and asynchronously push it to the broker. In our case, what we're gonna do, inside our push service, we're gonna store the incoming events into a Postgre database table, and only then we're gonna send the messages to the events queue via a cron job. So without further ado, let's take a look at the implementation and how does it work. So we're gonna go to the push service. Over here we have routing, and I have set everything in place before this video, so we're just gonna go through the implementation itself. We have the push service endpoints, and I'll zoom in a little bit so you can see better over here. Inside the configure endpoints, we have a single endpoint that gets injected a push service with a process incoming event, and we basically send the event and then return the results okay. This process incoming event, basically what it does is creates the message, the envelope for the payload. We're just basically setting up the routing key, and then inside the Outbox service, we're just gonna store the message. The Outbox service basically has only two methods, which are store message and process existing messages. And right now we see a small mistake I did here. This method should have an async suffix to it. So basically we're just gonna add a simple Outbox message data model to our table in our Postgre database and save changes async. No big deal over here. And inside the process existing messages async, we're just gonna fetch the existing events where the processed on is equals to null. Basically it has not been processed. And then for each, we're just gonna iterate over it, publish the message over to our broker, mark the message as processed on a specific data. Then if we caught an exception, we're just gonna mark the message as processed, we're gonna set the error and log the error itself to the log management. Next, we're gonna mark the message data for update. Since we're using entity framework, we need to do that. And finally, we want to save the changes async to our local database. And if anything happens during the save changes async, we're just gonna do the same thing. Catch an exception and log it to our log management solution. For the rest of the plumbing code, we have here an Outbox folder where we have the data model itself, where we basically have the message ID, the header, the body. You might want to combine these two into a single property. I prefer having them separate since from time to time I had to do some operations on the header and the body itself was quite large and I didn't want to deserialize the whole thing if I needed just a couple of properties from the header. The cordon, basically when the event has been triggered, the process on as a nullable field, the error as a nullable field, and the routing key, in case you need one. Next we have the data model configuration, pretty straightforward. We have the has column type as JSON, which is specific to Postgres database. If you're using SQL Server, you might just save it as a text column and nothing else. But since I'm using Postgres, I want to take profit from its capabilities. Next, we have a simple DB context with a single table and basically applying configurations from its own assembly. Now the fun part is the installer and the cron job that picks up the messages and sends them to the message broker. For the cron job, I used Hangfire for a simple system. You might use something like the native background job, or better use Quartz, not go the full blown Hangfire stuff, but I prefer Hangfire, and I have another reason to use it in a later video. Inside the installer, and let me make it full screen right now, we have the add_RabbitMQ Outbox method, where we basically retrieve the connection string to our default database. We set up the DB context, we add a scoped Outbox service, then we're gonna use the connection factory, and this is apparently the new way to set up Hangfire. I haven't used the new way before. This part is not mentioned in the documentation, but I've run a couple of times into this issue. You're gonna have to set up the current job storage. Maybe I missed it when I was reading the documentation, but this is basically an annoying issue that I've had a couple of times. And then you're just gonna set up the recurring job, add or update. You're gonna send an ID to the recurring job, which in our case is Outbox relay, and set up it to be an Outbox service, process existing messages async, and I want to process the messages every minute. Finally, you're gonna want to add Hangfire server. Other than that, the other method is just basically applying the Outbox migrations, which we've seen a couple of times already. Worthwhile, we might take a look at push service installer, where we basically set up the RabbitMQ Outbox. And inside the program.cs, I've also specified to use the Hangfire dashboard for a fancy UI over the recurring jobs. Now let's take a look at the application that has been apparently running in the background without me noticing, and we're just gonna execute our request and hit our first breakpoint, basically go to add async, save changes, and then continue. In a minute we're gonna hit the process existing messages, and over here we have it. So the existing messages itself, we're gonna take a look at its one. Next, we're just gonna iterate over each one of those and basically publish the message, mark it as processed, update, and then save changes async to our database and continue. And let me just remove this breakpoint from over here and bring over a SQL query over here. So we just want to run for all our existing events. If we execute this query, we basically are gonna get the event and the message that we have saved to our database with an ID, the header, the body itself, occurred on when the event has occurred, when the event has been processed. If there was any kind of error, we would have it here. And then we have the routing key, which we need to push the message further downstream. So yeah, that was it for this video. Hope you liked it. And if yes, leave a thumbs up to the video, subscribe to the channel, leave a comment with what you want me to cover next. And yeah, see you next time. Bye.